So in this video, we will consider these three examples and find out if the function f of x is continuous or not in each of the problems. So first problem is f of x is equal to x plus 1 for x less than or equal to 0, and f of x is equal to e to the power of x for x greater than 0. So we will say in terms of graph. Okay, so this is f of x. See, at x is equal to 0, you have x plus 1. So 0 plus 1, it will be 1, right? So 0 is included in that. Now what happens? For less than 0, that means if you consider minus 1 now. Minus 1 means it will be 0. For minus 2, it will be equal to minus 1. So what happens? It will be like this. Okay, it goes till minus infinity. It goes to infinity. Okay. So e to the power of x. So next if you consider on the positive side, so for 1 it is e. So what happens? This one will be your growing exponential signal. So like this, something like this, it will be e to the power of x. Okay. So you can see like at 0 you have value 1. Okay. So f of 0 that will be equal to 1. And this can be written or this graph can be drawn without lifting my pen, right? So this is a continuous function. So we, by mathematical definition, we will try to solve this. Okay. So f of 0 that is equal to 1. Next, if you consider left hand limit, that is equal to limit f of x is nothing but it is x plus 1. Here if I substitute x as 0, then it becomes 1. So now if I consider this is left hand limit, this is right hand limit, f of x that is equal to limit which is approaching 0, that is from right at the point 0, e to the power of x, so e to the power of 0 that will be equal to 1. So you can say LHL left hand limit that is equal to right hand limit that is equal to f of 0 which is equal to 1. So this function f of x is continuous. Okay, so it is continuous. It is continuous from both left and right at the point A. Okay, from both left and right at the point A. So next question is f of x is equal to x square minus 1 divided by x minus 1. Now if I substitute x is equal to 1 in this equation, what happens? 1 minus 1 divided by 1 minus 1, that is equal to 0 by 0, which is undefined, right? It is undefined at 1. Or else for the rest of the values you can take x square minus 1 as x plus 1, x minus 1, x minus 1, right? So you will get x plus 1. So if you take this, at x is equal to 1, it is undefined. But at x is equal to 0, you have 1. At x is equal to 2, you have 3. Okay, you have 3. At x is equal to minus 1, you have 0. Okay, you have like this. But here at x is equal to 1, it is not defined. So what happens? This one will be obviously a discontinuous function, right? We do not know the value at x is equal to 1. So this is a discontinuous function. So this is a rational function. X square minus 1 divided by x minus 1, this is a rational function. It is continuous everywhere except where the denominator equates to 0. So x minus 1 is equal to 0. So it is continuous everywhere except x is equal to 1. So the third is f of x is equal to 5 for x less than minus 2, and it is equal to x minus 1 for x greater than or equal to minus 2. So graphically how we will write this? See, if I consider this is minus 2, minus 3, minus 4. This is, see it is less than minus 2 means minus 2 is not included. So we will be having the open circle there. So this is the value 5. This is not included, so I will consider an open circle then. So at x is equal to minus 2, we have minus 3. Okay. At x is equal to minus 1, we have minus 2. At x is equal to 0, we have minus 1. Okay. And at x is equal to 1, we have 0. At x is equal to 2, we have 1. So something like that. It should be a straight line. Okay. Just, I'm very bad at drawing. So just, it should be a straight line. So what happens here? You can see there is a jump discontinuity, right? It is a jump discontinuity because left hand limit will be 1, right hand limit will be 1. You can see here there is a discontinuity. It is not continuous because after drawing this, if I want to draw this, I have to lift my pen and then I have to come here, right? So this is a discontinuous function. So mathematically how I will tell you. See, at x is equal to minus 2, we have minus 2 minus 1, that is equal to 3, minus 3. Okay. So if I take the left hand limit now, left hand limit, that is limit, it is 5, that is equal to 5. Next, if I consider right hand limit, it is x minus 1. So substitute there, it will be equal to minus 3. So we can say that LHL is not equal to RHL. Okay. But we can say this is continuous from the right at point minus 2. It is continuous from the right. Okay. Because RHL is equal to, RHL will be equal to f of minus 2. Okay. So this is continuous from right at the point minus 2.